I'm just going to do simple values. Int a equals 5. Int b equals 7. Now what I should be able to do is I should be able to add these two together, and I'm going to save that in a spot. Int c equals, I want to save the adding of these two numbers together, so what I'm going to put on this side, I'm going to put a plus b. Now I don't need all these spaces in here. I like them in there so that it just spread things out and it's easier to see. I'm going to put some more stuff down here because what happens right now if I upload this to my board, it says that it's uploading, and it uploaded. That means it solved this problem. The problem is, did it do it right? What is that value? Now I know that this should be 12, but how do I know that it knows it should be 12? How can I double check that because nothing's here? I'm going to solve that with the serial print. Serial.begin 9600, and then serial.print C. Now do I want quotation marks here or not? If I put quotation marks, it's going to print the letter C. If I do not use quotation marks, it's going to go back into memory, find something called C, and print it. That's what I would like here. So let's go ahead and upload this real quick. Open the side by side so it's easier for us to see, and we do see that it's 12. All right, what happens if I change this to a minus sign? Can I subtract? Yes, you can. What should I get? -2. That's what it should be. Great. Now let's say I was trying to be really fancy and all that, and I put unsigned right here. I'm like, I want to be able to do larger numbers with integers, all that good stuff, and I try to do this. What's going to happen when I have this negative in here? Is it going to just drop the negative sign? Is it going to give me an error? An error would be great, but let's see what does happen so that you can be prepared for it. It's compiling. Hey, it didn't find an error. It's uploading. Now it prints this. That's weird. That's not even close to 2 or -2. So what's happening? What's happening is, remember, this is my range of variables. And so once it gets down to 0, if it were to go 1 less, what does it do? It starts here. And if it goes 1 less, then it's 1 less than this number. And since we are at -2, it should be 1 less than this number, because this would be 1 less than 0. A little confusing. We'll talk about that probably in class a little bit more. All right, so you got to be very careful when choosing your data types. You got to be very careful. All right, what else can we do? Can we multiply? To multiply, we use the asterisk. There we go. Upload. And we get the number 35, so that's great. All right, and then lastly, can we divide? Yes, we can. We use the / for that. And what value should we get for that? Well, that's going to be 5 divided by 7, which is going to be 0. Well, it's not 0. What happens if we don't use the right data type? If there's going to be a decimal, it does not round. What it does is it truncates. Anything less than 1, and it just loses all that data at the end. So this is going to be 0 point something. All that point somethings go away, and it just gives me 0. How do I fix that? Float. I'm going to upload that, see what happens. All right, now it gives me an error, and I've seen this before. Sometimes this happens when you print because the cord that you connect the Arduino to upload the code is the same cord that it uses to send data. And so sometimes you just need to give it a little bit of a delay, just so that it has time to kind of move everything out of the way, make sure everything's uploaded first. And it doesn't have to be long. Remember, this is in milliseconds. Very, very quickly. Now it says that it's 0.00. And so again, you might be a little curious to say, you know what, it shouldn't be that. Now, the problem here is it's trying to take something that's an integer and then turn it into a decimal. What we need to do is we need to make sure that the inputs are also capable of a decimal. And then we should be able to get a value. Now, it's only going to print up to two decimal places. There will be more precision saved. I believe it's 8 spots will be saved in memory. But we only get to see 2 here. So those are some options, some things that we have there. Starting off with some of our operators. Now I'm going to go ahead and I'm going to keep this in the setup. And I want to come down here to the loop for a second. And I want to make a global variable. We'll go byte x equals 0. All right, so I'm going to start off with a number, the number 0, and I'm going to call that x. And I'm going to say x plus plus. This is called their incrementing operator. What it'll do is it'll take whatever's saved in the spot x and it will add 1 to it. So the very first time it does this, serial.println x, and yes, I see that misspelling. I'll go back and fix it. There you go. So what it's going to do, this is 0. It's going to add 1 to it, so now it's 1. It's going to print the number 1. Remember, this is in our loop now, so then it's going to take, come up here, it's going to look in memory, it's going to find the number 1 and add 1 to it. Now it equals 2, then it's going to find 2, now it equals 3, and it's going to keep cycling through. So let's double check to see how this works. Okay, it whips through things, and you'll see that it keeps starting over. It's moving really, really fast. A lot of times when we're going to do prints, it's nice to put in some delays. Even if they're not very long, just maybe 50 milliseconds, just so I can actually do a little bit of reading here. See what's happening. Compiling. It doesn't like that delay, does it? Alright, we'll take that out for just now. We'll see what's going on. But adding delays can definitely help you read what's happening a little bit better. If for some reason I can't get that working for a second, I'll have to double check what's happening there. But what I want to do real quick is I want to move on to the other one. I have what's called decrementing. This is incrementing, it goes up. Decrementing would be minus minus. And what would happen if I start this off as an integer? It should be able to go into the negative region. And I do think it would be nice if you guys could practice some of this. Just see what happens when you type these in. You'll see that it keeps going up and up and up and up, and it's going to go up until it reaches the minimum value, which is going to take a while. And then we'll be able to get to, once it gets down to this very bottom one, so here we go, integer, once it gets down to this number, the next number it's going to find is this one. And then it's going to cycle down until it gets to 0, keep going, and it'll just keep looping around this way. So those are our incrementing and decrementing operators. There are a couple other ways to write this. I could also write equals, and this is where it can be somewhat confusing. The same thing as x plus plus could be written as x equals, that's my assignment operator. I'm going to do something over here and say, take x, add 1 to it, and resave it. There we go. Now, if you were to show up to math class and write this, everybody'd freak out. Horrible, you can't do that. It doesn't work because you can't have a variable, add something to it, and end up with that same variable again. You have to remember that this is a computer language. What it's doing is this is not saying it's equal. This is assigning a value. it's going to look in memory. It's going to do this right side first. It's going to look in memory, see what's saved here. It's going to add 1 to it, and once it gets this value, it's going to assign it and overwrite what was in X, and then print it. And it's going to come up here, it's going to check to see what is now currently saved in X, add 1 to it, print it, assign it to live in X now, and then it will look in memory and print the updated value. So there we go, now it's counting up. So there are a few other things we can do. You can always look at a cheat sheet to see some of these. Here are our compound operators. So we have the plus plus, the minus minus. Then we have some of these compound things here. A plus equals, a minus equals. What do those ones do? Those ones are kind of fun. Let's say that instead of adding 1, I wanted to add 5 every time. I could write it like this. Upload. And you can see that it's going up by 5s. It's kind of hard to see. So one thing you can do is you can click auto scroll. Boom. Stops. You'll see that it keeps printing. But now I can kind of scroll and see different things, and then I can click auto scroll again. It'll snap back down to here and keep going. I can stop it again, but you'll see that they're going up by 5s. Okay, that's good. But what I could do is I could change this and write it like this, shorthand. It's going to just increment by 5. We see that in this cheat sheet here. We have our plus equals. We've got to flip it. I forgot that. So we've got to flip that. Plus equals. It's going to do the exact same thing. And it does do some weird stuff when you upload, so just be aware of that. So I took my auto scroll off. Click on it. We'll see that it is working here. All right. So we do have different types of operators we can use, and you can do this with all of them. You can do this with subtraction. Count down by 5s. We could do this with multiplication. We could multiply each new one by 5. It's going to grow much faster. Well, in this case, it's not, because we started off at 0. So what I could do is I could start off at 5. And again, this is why we like our serial monitor. Sometimes we just make a change, we assume we know it's going to happen, but it doesn't work quite right. So, wow, lots of weird stuff here. Starts off at 25, this was old information, 25, 125, and it grows super fast, and it keeps going to these negative things. So what I could do is I could make this a long. Long gives me more storage. So if we know that it's going to get big, I can make it big faster. You'll see that it still will eventually get too big, but it lets me get much, much bigger. And then I can also use my division. Upload. Zero, 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 zero. I have no decimals here. Double. Double's like a float, except for it will hold more data, but the last time I checked, that's true in C++. Last time I checked in Arduino, the double and the float actually held the same size, and so they can be used interchangeably, but this is just one that will hold a decimal. And again, you'll see that it gets small very, very quickly because it only shows us up to 2 decimal places. Now there's more stored in here if I wanted to use it, but up to a certain point, I start losing information. So you see that it just gets smaller and smaller and smaller and smaller. It's not going to start over because it's getting closer and closer to 0. It's never going to come around and start over because it gets the end of either the minimum or the maximum of a data point here.